Right, working with design patterns. Okay, and it's going to have the following things in it. So it's going to have examples. It's going to have a class called Hey Storage. It's going to have a main. It's going to have a class called Meet Storage. It's going to have a class called Vegetable Storage. It's going to have a class called Zoo Keeper. Okay, so create that. That's the name of the class. 2.5a, working with design principles. Okay, so new Java project F 2.5a, working with design principles. Finish. So gonna put in new class examples. Oops, shit. Android. So hey, storage, new class main, meet storage, next one is vegetable storage, and the last one is zookeeper. Right. And main should have public static void main string x. Right. Now, so the first thing we're going to there's four of these topics we're going to do now. Design principles. Okay. Now, it's not working with design principles. It's design patterns. Sorry, it's design patterns. Name that. Resource, refactor, rename. Okay. Working with design patterns. Now, so design principles, stuff like is a, has a, Java beans. Okay. Now, design patterns, we deal with four of them. Okay. First one we deal with is something called, again, these are ways of doing things, okay, but they're a bit more involved than design principles. Okay. So design principles is more kind of about your overall way you're designing software. Okay. Design patterns is more concerning with particular bits of code. So that's how I define the two of the difference. Design principle is more your overarching way you produce your code. Design patterns, it's for a specific piece of code. Okay, so there's four ones we're going to deal with. First ones we're going to deal with is something called a singleton. Okay. Next thing we're going to deal with is immutable classes. Now we're going to be creating these. Okay. Next thing we're going to deal with is something called the builder pattern. Last one we're going to deal with is the factory pattern. Now, the most difficult of those is this one. All right, which is the first one we're going to do. All right, now, what's a singleton? A singleton means that only one of these objects will be created in your application. Okay, so anything that is only going to be used once, or sorry, anything that you only want one of in your application. For instance, to get technical, a database connection. All right, you want only one connection to one database at one time. All right, so you can only connect to one database, we're saying here. Okay, so if you create a connection that's a singleton, doesn't matter how many more times you go to create another database connection, you'll still only have the one database connection. Do we understand that? Yeah, so that means you can only have one. So now you can close the connection, basically you get rid of it, so then you have a different database connection. But while the database connection is open, you only have one of them. Yes? Understand that? Right. Now, another thing. Here we're going to do the example of a zoo. All right? Now, when you have a zoo, one of the main things you have to do is manage the amount of food that you give to your animals. Okay? So, what I'm going to say in our zoo is all the animals that eat. So we're going to have animals that eat hay, such as an elephant, such as zebras, such as giraffes. They all eat hay, right? And there's a central storage for the hay. All right? Now, every animal is going to be accessing the same hay storage. Do we understand that? Yes? So we only have one hay storage for all of our animals. The zookeeper is going to be accessing the hay for the animals. So the animals and the zookeeper are going to be accessing the same hay storage. All right? The same barn. That's going to be a singleton. All right? We're not going to have two hay storages. We only have one of them. Similar, the animals that eat meat, lions, tigers, bears. Okay? We're going to have something called a meat storage, and it's going to be a singleton. There's only going to be one of them. All right? Now, the thing about this singleton is the meat storage. You're going to be taking meat away from it. So the tiger eats 1 kilo of meat. The lion eats 2 kilos of meat. The bear eats 3 kilos of meat. Okay? You started off with 100 kilos, take away 3, take away 2, take away 1. You now have 94 kilos of meat. You can add things to the storage. You can take things away from the storage, but it's still the same object. You understand me? That's what a singleton is. It's one object and one object only. And it can be accessed by different methods, but it's still the same object you're all accessing. Yes, it is a static. Okay? Or it's a special static. Okay? That's what a singleton is. All right? Now, immutable. You have come across an immutable class already. It's a string. All right? Now, we will be creating an immutable class. That means you create an object of that class, means it doesn't change. Okay? It doesn't change.
Tom Costello, please call to reception. Tom Costello, please call to reception.
Now you can assign something new to it. That means it's going to be a new object. Do we understand that? What I mean by, so if I go string my str is equal to banana, okay? I can't change that, but I can assign a new string to it. So I can change that to orange, different string. It's not modifying the existing string, it's assigning a brand new string to it. So we're going to be creating a class like that. Okay, obviously there's going to be a final class. So there's a couple of techniques. So Singleton, only one of them. One is created and one only. And even if you trim to create other instances of it, it's still accessing the same object. All right. So you can have multiple objects accessing the same object. All right. So an example of a singleton would be this building. Okay. We all come to this building. Okay. Could say that this building is a singleton to us. It is a static, but it's a special type of static. Now the builder pattern. Now, I'm just going to get rid of all of this shit for a minute. Now this is very useful, this thing. When you get used to this, this is very useful. Now, when we're creating an object, we use constructors, yes? Yeah? Now, all of the classes we've been using, all of the objects we've been using, the classes don't have that many variables inside them. All right? However, let's say you have a class called person. And this class has got, now this would be a lot, 1,000 variables. Okay? That means to create a person with all of those variables, we would have to have a constructor that would have 1,000 parameters in it, which obviously is going to be too big, right? And that's not even getting into, think about all the different variations of a constructor. You might want to create a person that only has a name. You might want to create a person that only has a name and an age. You might want to create a person that doesn't have a name and an age and is just blank. All right? So you'd have to create a constructor for all the variations of the person you want to create. Do you understand that? So let's just say, to break it down even a bit simpler. So we have a person class. And we have an int age. We have a string name. We have a double weight. Now, by using constructors, if we want to create a person that only has an age, we have to create a constructor person int age. If we want to create a person with only a name, we have to create a constructor person string name. If we want to create a person with only a weight, we go person double weight. If I want to create a person that has none of these things, person. If you want to create one that has an int, that has an age and a name, we have to go person int age string name. If we want one that's taken an int or an age and a weight, we go person int double. If we want a person that has all of those variables, we go person int string double. So even with 3 variables, you can see you can end up with a lot of constructors. All right. And obviously that's confusing and it's time consuming and it's a pain in the arse. All right. Now, the builder pattern is an attempt to make this much, much simpler. All right. you basically do is you have all these methods. They're called setter methods. They're setter methods. Okay. So if I want to create, so again, we have our person class, and we just have int age, string name, double weight. Rather than having a load of different constructors, we have 2 or 3 special methods that allow you to do something like this. You create a, let's say, you'd have a class called person builder. So I want to create a person that only has an age. So person builder dot set age dot build. So person builder dot set age dot build, that will make you a person that only has an age. If you want to create a person that only has no variables, you would go person builder dot build. That will create a person with none of those variables. All right. So rather than having literally, you could end up with thousands of constructors. You create a separate class. The class is going to be the name of the class you're building for with the word builder, and that will do all the work for you. It's not that big of a class either. That uses something called the builder pattern. So rather than having thousands of constructors, you have another class called a builder class that will make the objects for you. All right. So person builder.build is going to build you a person with none of these. Person builder.set age.build is going to create you a person with an age. Person builder.set age.set name.build is going to create a person with an age and a name. All right. Very, very useful. Now, the last design pattern we're going to be using is the factory pattern. Now, factory pattern. Now, usually when we create objects, we know what we're going to create. All right. So I say to you, create a monkey. So you simply go along and you go, monkey, my monkey is equal to new monkey. So you hard coded it. All right. Now, however, let's say your code is running, and what type of object that's going to be created depends on some input from the user, all right, or depends on the time of day, or depends on some other object does something that causes some other object to do something else, which causes another object to do something else. Okay, so what the factory pattern allows you to do, it allows you to create objects on the fly. What that means is only certain objects will be created under certain conditions. So if it's at 12 o'clock in the day, create a monkey. If it's 12:15, create a horse. Um, if the person is vegetarian, serve them a vegan sausage. If they're not, serve them a pork sausage. Okay. So what the factory pattern allows you to do, it allows you to create objects at runtime. So as your code is running, the objects aren't set. It depends on what happens at a certain point in your code. The factory pattern allows you to do that. All right. It's just basically switch statements. It's the best way to describe it. Now, so we are going to start with singletons. All right. So Now, we should have all these classes. Examples, hay storage, main, meat storage, vegetable storage, zookeeper. All right. So before I tell you what we're going to try to do, we're going to create a singleton class to start off with. All right. So I'm just going to minimize all of this shit here. Now, as well, there's 3 different implementations of singleton. All right. I can't think of the name of the first one. I don't know what the name is. The second version is something called using static initializers to create a singleton. The third way is something called lazy instantiation of a singleton. All right. I don't know what they call the first version. I have to find out the name of it. But so, first one we're going to go to is, so I'm going to give a definition of the singleton first. Okay. Right. So up here in main. So I give it a definition. I have a definition here of a design pattern. So a design pattern is an established general solution to commonly occurring software development problems. Now, I don't know, I think this definition comes up, so that's why I'm putting it in. Something called level of indirection is a general term for solving a design problem by conceptually separating the task into multiple levels. Now, that sounds like highfalutin terms. All it means is that it doesn't matter how complicated your problem is, if you break it down into smaller problems, the problem becomes easier. Okay? So you're trying to develop something that's really, really, really complicated. All right? You don't try to solve it as a whole. You break it down. Let's say you have a massive problem. Well, what you do is you break it down to 1,000 smaller problems. All right? That's what software development is all about. It's all about breaking down things. Easiest way to break down a big problem in software is create a method. So each one of your methods should be solving a little part of the problem. All right. Now it's a skill in itself, by the way, to be able to break down a really complicated problem into smaller things. All right. Now you can use some graphic tools are very handy. UML. What's UML? UML is just diagrams. Right. So there's no problem that can be made less difficult. Okay. You break it down into smaller tasks and you try and sort out each one of those tasks. How do we sort out each task? Now, we can use something called the agile methodology. The agile methodology is just a way of doing things. The agile methodology is you divide up your problems into smaller problems. These smaller problems are called scrums and sprints. All right. If you hopefully they'll have it installed sometime. Jira. Jira is for managing scrums, sprints. A scrum is made up of smaller sprints. All right. Project manager's job is to manage, or a scrum master. What their job is to manage the jobs. So what they do is you log into your Jira, you'll see all these little issues. Create a logo. Create GUI for our first screen. Create GUI for our second screen. Create GUI for our third screen. All right. And so you come in then as a software developer, you mark it as doing, I do that problem. It's marked. So anyone else come in can see Jason is working on our GUI. Roland is working on our second GUI. All right. You finish your sprint, your market is done. If all the sprints are finished in a scrum, your market is a scrum done. All right. So level of indirection is general. So all this level indirection, it just means breaking your big problem into smaller problems. All right, and that feeds into the agile methodology, which you can use something called Jira to manage the agile methodology. Okay, which we will be doing. It's not examinable, but we'll have to learn how to do it. Okay. Now, so I'm going to go to examples. So Singleton pattern. So this is going to be static void ex1. And I'm going to say Gleton pattern. Okay. Now I'm going to put a comment above that. So create a single object that is shared across multiple classes. Okay, so why would you do this? This can remove a large amount of confusion. So several different objects that are essentially same object but can have different properties. To change one mightn't change the other. All right. So in our case, a hay storage and a meat storage object. Okay. Our zoo and has animals and zookeepers. Okay. And each of these classes uses the same hay storage and meat storage.
General Assistant, contact the back gate. General Assistant, contact the back gate. Thank you.
Our zoo has animals and zookeepers, and each of these classes use the same hay storage and meat storage object to keep track of how much meat, much hay and meat you have in stock. Okay, we can add meat and hay, and we can take away meat and hay. Okay, so it's the same object. So you can imagine we're taking hay from the hay barn. All right, if we take out too much, we're going to automatically say ring up our suppliers. It's automatically going to send an email to our supplier saying, "Hi there, Tom, deliver us another 100 bales of hay." All right. So Tom delivers 100 bales of hay. So then our hay storage uh, object shows we've more hay. Meat storage object. So start off with 100 kg. Zookeeper comes along. He feeds a tiger, a bear, and a lion. Tiger takes 2 kilos, a bear takes 1 kilo, a lion takes 3 kilos. That's 6 kilos taken away. That means we have 94 kgs of meat left. Keep doing that. If we're nearing a minimum amount of meat, If we go below that level, it'll say you're not allowed to take out any more meat. It'll automatically contact our resupplier, our butcher, saying, pat the butcher, give us another 50 kilos of meat. Okay? So if you have a singleton, you don't have to be juggling different meats. If you didn't have a singleton, right? If you had a meat storage for every animal, they're painful to use. If you just have one of them, right, you're just adding and taking away. A shop is going to operate the exact same way. All right. Imagine you are Tesco. Okay. Tesco will probably have one object called stock. Okay. Now this stock is going to be made up of thousands of variables. All right. Because they're going to have a variable, let's say, for beans, another one for bread, another one for milk, another one for butter. Okay. We start off at the start of the day with 1,000 cans of beans. We start off with 500 loaves of bread. We start off with 1,000 litres of milk, and we start off with 2,000 packets of butter. Okay. As the day goes on, people are buying butter, buying beans. Okay, buying beans. So this figure here gets down to 500. People are buying bread. This goes down to 100. People are buying milk. This goes down to 150. People are buying butter. This goes down to 1,500. If it goes below a certain level, we will say if stock.beans is less than 500, order more beans. It's just the one object. Okay, we don't need a separate stock object for beans or bread or milk or butter. Okay, it's just the one object. We just have a singleton stock object. Does everyone understand that? Yeah, it makes things a lot simpler. Now, they're a little bit difficult to set up. Now, here's where frameworks come into. So we're going to learn how to do it manually. However, if you use a framework can set up a singleton for you. Right? It can set up mutable classes for you. It can set up the builder pattern for you. It can set up the factory pattern for you. That's the beauty of frameworks. It does all of this for you automatically. Now you have to set up how you create singletons. You have to set up how you create builder patterns. You have to set up how you create factory patterns. You have to set up how you create immutable patterns. But once you have it set up, it's just a matter of clicking a button, your singleton is created for any class. All right. So the one I'd be most familiar with would be Spring. So when we have the exam done, we will be looking at Spring to automatically create these things for you. Is that okay, everyone? Yes? Blank stares. Huh? Yeah. Well, the values here. Yeah, yeah, yeah. So all of these here would be values retrieved from a database. Yeah. Okay. But stock could be an object that would contain the amount of beans, the amount of bread, the amount of milk, the amount of butter. But all those values, yes, will be got from the database. Yeah, they would be. And you would also be adding and taking away from the database as you're taking things away. So Tesco operate a thing called just in time. So they don't actually hold many. They don't hold much stock in the actual shop itself. All right. Okay. Um. So the way they operate is they know from the tills, right? They know that 500 beans have been checked out. right? So they're going to say if it goes below 500, so if 500 beans have been checked out, that means there's only 500 beans left on the counter or left on the shelves. So a message is sent to their stock room or to the lads, restock with another 500 cans of beans. Okay? The Singleton they use. Absolutely positively sure they use a Singleton. Okay? So, so we can take away meat and hay. So similar, so we can do the exact same process for the stock in a shop. Okay? So we can do, you can imagine you have one Singleton called shop. Now you can have a Singleton for meat, you can have a Singleton for all your different categories of grocery if you want to do it that way, or you can have a Singleton that covers all your products in your shop. Probably the bigger the shop, you're going to have a Singleton for meat. You'll have a Singleton for confectionery. You'll have a Singleton for canned goods. You'll have a Singleton for vegetables. Okay? You'll have a Singleton for drinks. All right? So you can do the exact same process for the stock in a shop. Now, so what Singleton removes the need to pass around the object. Okay? So you could create an object of the class, of a class, right? And you could say that the lion gets a hold of the hay storage object, it does something to it, but you have to send it to a method. The tiger gets a hold of the meat storage object, it does something to it, but again, you'd have to send it to the tiger. With a Singleton, you don't have to send it anywhere, you just access the Singleton. Okay, it doesn't matter where the Singleton was first created, there's only one of them. So if a lion is the first class to access the Singleton, it's a static. So if the lion is the first thing to access that Singleton, doesn't matter what accesses it after that, it's accessing the same meat storage. Okay? So what we're doing here is we have a zoo. Okay? And the zoo has a fridge that contains all the meat. Okay? The zoo has a barn that stores all the hay. The zoo has a cold storage room that stores all the vegetables. Now, there's only one of those, so we are going to create, where we store all the meat, we're going to create a Singleton Java object called meat storage. We are going to create a Singleton hay object where all our hay is going to be stored, and we're going to call it hay storage. We're going to create a Singleton Java object representing the cold room where all our vegetables are stored, and we're going to call this vegetable storage. Okay, so a Singleton again, it more reflects real life. All right, so the more your software can resemble real life, the easier it is to understand. Simple as that. Okay, so a Singleton is another way for you to resemble real life. All right, so it's easier to understand, and it is more effective as well, by the way. It's more effective than each animal having its own storage object, because then you have to say if it's if it doesn't eat meat, it has to use a hay storage method. All right, now we're going to start doing it. Actually, we're not going to start doing it because it is lunchtime. So go to lunch, folks, and we'll start on the hay storage object after lunch. Stop that. We're going to be doing singletons. I explained before lunch what a singleton is. A singleton is a single object. There's only one of them per application. So I did the example of, I'm doing the examples of the zoo. So all of your meat is going to be stored in a freezer. Yeah. All of the hay is going to be stored in a shed. All of the vegetables are going to be stored in a cooler. Yeah. Right. So we're going to have a program. We're going to have all the animals, and the zookeepers who feed the animals are going to be accessing the one meat storage singleton. Okay, there's one of them. So we're going to start off, let's say, with 100 kg of meat. Okay, the zookeeper is going to take, so every animal is going to have a set allocation of meat. Okay, so we'll say a lion takes 1 kilo, a tiger takes 2 kilos, a bear takes 2 kilos. Okay, so if you're feeding 2 lions, that's 2 kilos gone from it. It becomes 98 kilos. If you're feeding 2 tigers, that's 4 kilos gone from it. That's 94 kilos. If you're feeding 5 bears, that's another 10 kilos gone from it. You're now at 84 kilos. Yes? Everyone understand that? So the zookeeper's doing his round. To make things easier, animals eat the same amount of food every day. Yes? So, which is probably going to be the way it's going to be in real life as well. All right? Now, we want our meat storage object. So let's say we start off with 100 kgs. All right? And we've done our rounds. And let's say we're down to 10 kgs of meat left. Yeah? And let's say we want to take out enough feed to feed 10 lions. Okay? And a lion takes, so 10 lions, and they take 2 kg each. All right? Now, so if the amount the zookeeper wants to take out is more than is left in the meat locker, what do you think we need to do? Sorry? Exactly. Okay. So if the amount we want to take them out, well, for start, we want to stop them from doing it. That's the first thing we want to do. Okay. And then we want to replenish it with, let's say, 100 kgs of meat. So if you attempt to take out more meat than meat that's in it, it's going to add 100 kgs of meat to that total. And then you can take out 20 kgs of meat. Does everyone understand that? Yes? So that's what we're trying to do. So we're going to do that for meat. We're going to do that for hay. We're going to do that for vegetables. All right? Now, we're going to have different animals accessing different storage places. Okay? Lions, tigers, bears are going to access the meat storage, Singleton. Elephants, zebras, and giraffes are going to be accessing hay. Rabbits, hippos, and some other animal I can't think of are going to be accessing the vegetables. Okay? You could also have something like a hippo will take hay and vegetables. So you can mix and match them up. Okay? Now, usually anything that takes meat does not take hay and vegetables. Usually. But not always. Some monkeys can eat meat and they eat vegetables as well. Okay? So do you understand what we're trying to do? So the main the main things we're looking at is the meat storage object, the hay storage object, and the vegetable storage object. Okay, now these three objects are going to be singleton classes. Okay, first one is going to use direct implementation of a singleton, I think it's called. Okay, the second method is going to use static initializers. The third method, which is the vegetable, is going to use something called lazy instantiation of the singleton. Okay, and I'm going to show you something here called double checking when we're doing lazy instantiation. All right, now lazy instantiation is something we're going to come across again and again. All right, it's a technique that applies to more than singletons. All right, what it basically means is we only create an object as we need it. Up until now, we create an object whether we need it or not. Lazy instantiation means the object is not created unless we need it. That's what lazy instantiation is. All right. Now, so we're going to start off. So we have all our options here. So the first singleton type is going to be hay storage. Okay. So go to the hay storage class. So just follow me for a minute and I'll explain what we're doing. Now, I want a way to uniquely identify. So to prove that only one object has been created, all right, I'm going to go static int counter is equal to 0. Okay. Now, when I create a hay storage object, that counter is going to increment by 1. Yes? So every time I create a hay storage object, that counter is going to. So if you were allowed to create 4 hay storage objects, you would have one with a counter. Now that's going to be used to give the ID to a hay storage object. Yes? Everyone understand that? Okay. So if I create more than one hay storage object, that number should be greater than 1. Does everyone understand that? Yes? So what I'm going to be doing is I'm going to be checking this number throughout the usage of the program to make sure it's still the same hay storage object. Yes? Okay. Now, what's that thing? What am I after doing there? That's a non-static because, yeah, there. Okay, so I should put, this will show how many hay storage objects have been created. And what is this? This is a non-static initializer. Now, so what does the non-static initializer do? Does it run every time you create an object? Yes or no? Yeah. Every time an object is created, the non-static initializer runs. All right. So I'm just going to say non-static initializer. Now, the non-static initializer runs every time a hay storage object is created, and it runs before constructor. Okay. Now, so this one, what's that? That's a static initializer. Now, static initializer runs only once. Do you understand that? Now, the second way we're going to create a singleton is we're going to create the singleton inside here. Okay? When we create the singleton inside here, this only runs once. All right? The only way we will create the meat storage object is inside here. Okay? We're not going to do that for the hay storage class. So I'm just putting one in there to show you that only one hay storage object is created. This will run just once. Okay? This always runs once and once alone. Okay? Just showing you that they do run before the constructor, and that so this one will run every time a hay storage object is created. So if only one hay storage object is created, this only runs once. Do you understand that? Static always runs only once. Okay? So we have this to show that only one hay storage object is created. Okay, this guy here, I'm just going to put inside here. I don't have to put in these ones for this class, but I'm going to put them in anyway just to show what's happening. So this is static initializer called. Okay, so this initializer can only access statics directly and will always only run once. Okay, important to note, any interaction with the hay storage class will cause this initializer to run. Right, so if we go, we haven't created a hay storage object. If you go hay storage dot call our static method, right, this static initializer will run. Okay, so any interaction with the hay storage class for the first time will cause this initializer to run, and it will be run only once. All right, so a static, if you're calling a static method of a class, that doesn't create an object of the class. All right, so hay storage, let's have a method called static method. Hay storage dot static method. We haven't done anything else with the class at this stage. Will cause this guy to run. Yes? Right. I'll show you. I'll go here to, I'll create a static method inside here storage. Okay. I'll call the static method static stat method. And static void. Okay. So I'm going to, so stat method called. So this is a static method inside the hay storage class. So if I go here and if I go hay storage dot stat method. Now we haven't created an object of the class. All right. However, I'm going to go here to main. Let's see what happens. So first of all, hey storage.stat method does not create an object of that class. Okay, but look what it's doing. It's calling the static initializer. Okay, so look what it's doing. So that's the stat method called. However, HStorage.stat method also causes the static initializer to run. Now the static initializer only runs once. So if I call the method again a second time round, so this is the method. But before the method is called, the static initializer is run. So the first time this method is called, that causes the static initializer to run. All right. So then it runs the method and we get that. We run the method a second time, static initializer doesn't run a second time. All right. Just the method calls. So the static initializer runs once and only once. And also the static initializer comes before everything else. So statics first, then and run it only once. Then we have the non-static initializers, which are run every time we create an object of the class. Then we have constructors. Now we haven't created an object of the class here. All right, we haven't created an object of the class here, which is why we'll go back to the storage class. This one doesn't run. The non-static initializer does not run because we haven't created an object of the class. Does everyone understand that? So statics first and run only once. Instance initializers run every time we create an object of the class. Okay, so if you just call a static method, which is HeyStorage.stat method, it runs the static initializer first, then it runs the stat method. If I run it again, it doesn't run the static initializer the second time round because it's only run once. Okay, so if we want something to run once, if our singleton is only going to run once, that obviously means we're going to have statics in it somewhere. Okay, that obviously means we're going to have a static in it somewhere, somehow. Okay, so does everyone understand the difference between static initializers and non-static initializers? Yes? Okay, because you need to know this before. Now, I know for the next method, we're going to be using, so for the next way of creating singletons, we're going to be using this to create our singletons. Yeah. Well, if it's an instance method, you have to create an object of the HStorage class first. So as soon as you do that, as soon as you create an instance of the class, the statics runs first, then that guy, then the constructor. So that'll go first, that'll be second, then the constructor. Okay, right. So we're getting into the mechanics of the class. All right, so I'll just leave that guy there for now. Now variables. So we need to record the amount of hay in the shed. Hay storage is a shed. That's all it is. Okay, so we want to record the amount of hay in the shed, and this quantity is going to be added to and going to be taken away from. Does everyone understand that? Okay, so we're going to make this private int quantity. So we're going to start off with a quantity of 100, presume kilos, or 100 bales. We haven't said what it is. Okay, we've just said 100. Could be 100 bales of hay. Could be 100 kilos. All right, so what is this? This is the amount of hay we have in store at any one time. Okay, so we will start off with quantity of 100. Now, we could get this initial value from the database to start off at the start of the day, and the value at the end of the day will be stored in the database. So it's a rolling. So at the start of the day, we have 100 bales of hay. All right. So bales are added to it, bales are taken away. So at the end of the day, that will be the quantity for the next day. Yes? Okay. So this is the daily quantity. This is the quantity at the start of the day. Now we could be getting it from a database. It could be just a file. All right. Doesn't even have to be a database. It could be just a file. It could be something that every day you just type it up in his keypad, or there's a running total being kept automatically. As you're checking stuff in and out, you could have a barcode system in operation. It knows that 5 bales have been taken out, or the zookeeper himself could enter in to say, I have taken out 5 bales. All right. Or if it was a shop and you were doing beans, it'll be all operating on barcodes. You take out a pallet of beans, there's 50 cans of beans in a pallet. It sees that you have 10 pallets being moved into the store. You know that there's been 500 cans of beans. Okay? And the scanner is linked up to that you beep on the way out. It sees that 400 cans of beans have been sold. That means there's only 100 cans of beans left, which will be included as the stock. Okay? So we're keeping a running total. Yes? Yeah? Right. Now, so we are going to have a constructor. All right? Now, we make the constructor private. Okay? Because we don't want to be able to create new hay storage objects. Yes? Okay? So it's going to be private hay storage. So I'm going to put it in here above it. Private constructor ensures we can't create a new singleton object outside of the class. Okay, as this is now the only way to create a hay storage object. See, object, we can't create a hay storage object directly outside of the class. So by making the constructor private means I can't go hay storage, my hay storage is equal to new hay storage outside of this class. Okay? But obviously we're going to the sum of the method. Now that prevents you from creating new hay storage objects outside of this class. Yes? Does everyone understand that? But it doesn't prevent you from creating new hay storage objects inside here. Right? You could create as many as you want inside this class. Does everyone understand that so far? Yes? Okay? So all I'm going to do in here, I want to know that a hay storage object is being created. Now, every hay storage object that's created is going to have an initial quantity of 100. Yes? Yeah? Now, we could get that figure from a database, as I've already said. You can start your application at the start of every day. It checks the database to see the quantity. When we shut all the cages last night, they take a note of the quantity. that's going to be the quantity at the start of today. Yes? Does everyone understand that? Okay. So, pay storage object created. So we should, if it's a true singleton, we always should see this message once. Okay. So if this is a true singleton, we should only see this message once. Okay. No matter what we do. Right. Oh yeah, I missed one here as well. Sorry. I should have said int ID. So this is going to uniquely identify the singleton. Right. So inside here, I'm going to go counter plus plus. Start it off at 0. And then I'm going to say ID is equal to counter. Okay, why is that giving me some error? Oops, sorry, wrong place. Sorry. Not there, not there. In the constructor. So counter plus plus. ID is equal to counter. So I do a counter plus plus. So that means if you have more than one haste storage object created, the ID will be more than one. That means it's not a singleton. Okay? So this increments our counter. So if your singleton, this increments our counter and sets the ID of the counter, so ID of the singleton, to be whatever counter is. So if the ID of the singleton is more than 1, it means more than one object has been created and it's not a singleton. Does everyone understand that so far? Yes? Huh? It starts off at 0. No, because I go counter plus plus. Oh shit, yeah. Sorry. No. Counter plus plus. Because the ID then is going to be 1. So counter plus plus. So then after that it's going to be 1. Okay, so ID will be 1. So ID should be 1. Okay. If anything else will not, it's not a singleton. Okay. I'm only putting in all these checks here to prove that it is a singleton. Okay. That's all. Right. Now, so here we come to the part that really makes it a singleton. All right. Now, so what I'm going to do, I'm going to go private. I'm going to go static. I'm going to go final. I'm going to go a haste storage object. You can have a haste storage object inside the haste storage class. Nothing wrong with that. Okay. Private static final haste storage is equal to new haste storage. Sorry, I didn't give it a name. Instance. Right. Now, so I'm going to write up a long comment for this one to explain what I've done here. So, first thing is, this is a final object, which means you can't change what the instance object refers to. Okay, so you can't change what the instance object refers to. So it will always refer to the same hey storage object instance. Now, so this ensures that once this object is created, the fact that it's final, okay, the fact that it's final means that this guy is always going to refer to this guy, okay? Private, you can't access it outside of this class. I'll explain the static in a minute. Okay, it's private means it can't be accessed outside this class, so it can't be changed outside of this class. The final means you can't change it. Okay, it'll always refer to this hey storage instance. Now, you can't change what it refers to, but you can change its variables, namely quantity. Okay, so it'll always be the same object, but you can change the quantity of the object. Okay, so it'll always refer to the same shed. Talking about the shed where we store our hay. But you can change the amount of hay that's stored in the shed. Does that make it clear? So we have a shed. There's our shed. And the shed is called instance. That's what our shed is called. Okay? And it always points to that shed. Right? You can't change the fact that instance refers, so this shed is called instance. Okay? What type of shed is it? It's a hay storage shed. Okay? It's a hay storage shed. That's the type it is. So sometimes it can have 100 bales of hay in it. You take away 50, then it only has 50 bales in it. But it's still the same shed. All right? This will always refer to this shed. So when you have an object that's final, you can't change what it refers to, but you can change the variables inside it, namely the amount or quantity, the quantity of bales. Okay, so now I have made it static. Okay, why have I made it static? The reason I have made it static is this is still this. What did I say about static initializers? What did I say about static initializers? They run before the class is created. All right, they run before the object is created, and they only run once. Okay, so this guy here is final, and it only happens once. So it only accesses the hay storage constructor once. Okay, now it's private, which means I'm going to be doing something. I'm going to have to access this somehow. Okay, right. Now, so I am going to have a method down here. Okay, I am going to go public static. It's returning a hay storage object. Get instance. And all we're doing is return instance. Now, so create a K storage object, all we have to do is the following, right? If I go hey storage dot get instance, so hey storage dot get instance. Okay, haven't accessed the class. I can't create a hey storage object anyway. Okay, so this is calling the statics of the class. Okay, hey storage, that is hey storage.get instance. That's a static method. But what happens before even this method is called? All of the statics run. So it creates the very calling this method for the first time creates that guy. That's something that's private, can only be accessed inside the class. Final, you can't change what instance refer to. It refers to our shed in the zoo. Okay, but you can't change the variables. Now, if I run this a second time, that doesn't run. If I run that a third time, that doesn't run. If I run it a fifth time, that doesn't run. All it's doing, it's accessing an existing static final variable. Okay, so the first time I run this, it creates it. Every other time it runs it, it's only accessing it. Now, the easiest way to show you is to show you an example. I want to put in a couple of comments first before I do that. All right, so this here, it'll always refer to the same hey storage object instance. However, we can change the variables of a final object. So we can change quantity of the hey storage object. Yeah. Because no. Yeah, well, I'll explain it again. It's no problem explaining it. Right. So we can't create an object directly because it's a private constructor. Right. So key things is these two lets. All right. Now this is a public method, so it's a static. So we can go hey storage dot get instance. Okay. Now that's a static. Now this is the very first time we run it. The very first time we run it, before the method is called, it runs all the statics. Okay, so it runs the static initial. Now it does the statics in order. So it will run this static. It'll run this static. Next thing it'll do, it doesn't matter. As long as they're static, it'll do them in the order. And it runs this one. So the first time you access the class, now if you could create an object, that would run as well. Now you can't create an object outside of the class. So the only thing you can access from outside of the class is that guy. Okay, now, so I'm accessing a static method. So I go, hey storage.get instance, runs all the statics. It runs that one before it runs this. So it's private, can't be accessed outside the class. It's static, means it's going to run before it runs once and once only. It's initializer. This is an initializer, just doesn't have the brackets around it. Okay, It's final. It means you can change, but you can change the variables of it. It's a hay storage object. It's going to be called instance. It creates, we're accessing the private constructor. We can only access this constructor from inside this class. So when we get to here, instance is already created. Return instance. So the first time we go hey storage.get instance, that's created. First time. And it returns the instance. The second time, that doesn't run because it's static. Static only runs once. Okay? Because this is an initializer. You can even do this if you want to. It's totally up to yourself. This is legal. Oh no, actually it won't be legal. So leave that out. So all your statics are given values the first time you do anything with the class. Okay? And that's the only time they're given values. Right, so put it in here. So here we are instantiating, I don't know how to spell this, the hay storage Singleton directly. Okay, so it's private, which means we can't access it outside of the class, so we won't be able to modify it outside of the class. It's static, so when we access a class when we access the class for the very first time, this static will be given a value. However, this happens once and only once. Okay? This won't run a second time. Okay? As this is a static initialized value, it will run the first time the class is accessed in any way. Okay? However, this will not run again. Okay, so this runs only once. So it's private, means you can't be accessed outside the class. It's static, so it runs once and only once. It's final, which means instance is always going to refer to this hay storage object, but you can change the quantity. Okay, that's the main thing we want to change. It's the only thing we want to change. Now, we're going to put it here. Another reason to make it static is you can't create an instance outside of this class. So we can't access this variable via an instance method. So if we have an ordinary method inside here, it'll be no good to us because we can't access it, because we can't create an object of this class outside of it. Do you understand that? Okay, so everything is interlinked. If we can't create an instance outside of this class, so we can't access this variable via an instance method, as instance methods can only be accessed by objects of the hay storage class. Okay, so we are accessing this via a static method. Okay. Now, this is the static method. When accessing by a static method, we go a storage dot get instance. Okay. Now, when accessed via a static method for the first time, we go hey storage dot get instance. Okay. This causes all statics in this class to be given values, including this guy. Okay. So when accessing via static method for the first time, we go hey storage.get instance. This causes all the statics in this class to be given values. So by very virtue of the fact of calling this method creates that the first time you run it. Yes? Okay. Right. Now, every subsequent call of a storage.get instance will not cause the statics in the class to be given values. It will use whatever values the statics currently have. Okay, so hey storage.get instance creates this guy. Run it a second time. Hey storage.get instance will just access that guy. Okay, I'm going to show you it in operation. All right. Now we haven't done this. We haven't finished this class yet. There's an awful lot more to it. Okay. Now, so I'm going to go to examples. Okay. Now I'm going to take out these two guys. I don't want them there anymore. Okay. So I am going to go hey storage dot get instance. Okay. I'm just going to put in here print statement so we can know what the method is called. Get instance called. Okay. I'm going to go back here to examples. So I'm going to go hey storage dot get instance. I'm going to do another one. Hey storage dot get instance. Now, there we have static initializer called. Okay, so all the statics are going to run. Non-static initializer called. Hey storage object created. So you can see that a hey storage object has been created. Okay, what object is being created? It is that object. Yes. Okay. Then it calls the get instance method. Okay, so that all up in the thing. Now, so when I run it the first time, so before the method is called, all this happens. Okay, then the method is called, that happens. The second time I call the method, all it does is call the method. Okay, so a singleton needs to be private, needs to be binary. needs to be static. Okay, it needs to be those three things. Go back to it again. Your singleton needs to be private. Your singleton needs to be static. Your singleton needs to be final. Okay, and you need to have a static method that accesses the singleton. That's the way they work. So I put it down here. Your singleton needs to have three things. Needs to have three things to work. First thing, constructor must be private. One. Okay, constructor must be private. You have to create an object of the class, inside the singleton class, that is private, static, and final. Okay. So your singleton needs to have these three things to work. Structure must be private. You have to create an object of the class inside the singleton class that is private, static, and final. Okay. You have to have static method that accesses the private, static, final variable. Okay. First time it runs, it will create singleton. Second times, subsequent times, it is run, it will just access the singleton. Okay, now that's what this way. There is other ways of creating your singleton, which we're going to do as well. Okay, so we have our object created, right? Now, so we have our object created, and just to prove that it's the right object, I am going to get the ID of the object here. So inside get instance. All right, so ID of object is, now if there's only one object being created, oh fuck, I can't access, sure. Plus counter. Okay, so counter should be 1. Yes, I only increment it. It increments only as an object is being created. No, I can't use ID because we're inside the static method. Okay, so this will show amount of objects created. Okay, so I'm going to run it. There we are. We'll see get instance called ID of object is 1, get instance called ID of object is 1. Okay, so there's only one object being created. So if you need to have a private constructor, you need to have a private static final instance of that class inside it. Okay, you then have to you only access that via a static method. Okay, that allows you to go hey storage.get instance. So this guy, put it here, this creates a hey storage instance object inside the hey storage class. Okay, this merely accesses the hay storage instance object already created. Okay, doesn't matter how many times you do it. Still ID of object is 1. Okay, so can we see how we create it? All right, so it is, there's 1 and 1 only. Now if you have spring, uh, which we will get a look at, it won't be till next year. It's a long, long way before we look at spring. Spring can manage all of this for you. Now you have to set spring up, so you have to set up how you want these singletons to be created. But once you have it done, you just click, and that does it for you. There's a fair amount of setting up to do with spring, and you have to know Java fairly well, but it will do it automatically for you. All right, now, so we have our singleton created. All right, now, so what does that create? That creates our shed, and it's got a quantity of 100 bales of hay. So that's that created. All right, now, if so, what do you think we need to have now? So zookeepers are going to be removing hay, animals are going to be removing hay, zookeepers are going to be adding hay, animals aren't going to be adding hay. Okay, so what do you think we need to have here? What else do you think we need to put in the class? A method to add hay, a method to remove hay. Okay, so put in here. I'll do the add hay, or sorry, I'll do the remove hay first. Okay, so now I'm going to do the method first, and then I'm going to explain what it is, because there is something new here that I need to put in. Oh, the keyboard is after. Right, now, so I'm going to create a method. So I'm going to remove hay first. I will say add hay first to hay. Okay, now, so I'm going to go public. Now I'm going to use this term, void add hay. Now I'll explain the synchronized in a minute. Into mount. Now I want the zookeeper to be able to choose the amount, basically. Okay, I could say when it gets to 0, add 100 to it if I wanted to, but I'm going to get the zookeeper to be able to say the actual amount it wants to add. Is that okay, everyone? Yes? Okay. So I'm going to say SYSO. I'm going to say amount. So amount here added. Okay. So I'm going to send an integer to it. That integer is going to be the amount of hay. So we'll say bales of hay. Okay. And then quantity. What's quantity? Quantity is one of the variables of the hay storage class. Okay, it's private, so it can only be accessed inside of the hay storage class. Now, it's just an ordinary variable though, It's not final. So that means we can change the quantity. So we're obviously going to have another method called remove hay. All right. So if a set amount of hay is removed, we didn't want to add hay. All right. So the amount of hay that's going to be stored then is going to be quantity plus equals. That's the wrong way around. Oh, it is. That's actually right. Sorry. Yeah. Amount. Okay. Where is it getting the quantity from? Quantity is the amount of hay that's in the shed. Okay. So whatever's in the shed, if there's nothing in the shed, if I add in 50 bales, then the quantity is going to be 50 bales. If there is 10 bales in the shed, I add in 50 bales. There's now going to be 60 bales in the shed. Yes? Okay. Right. Now, no, 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 I haven't. We could if we wanted to, but I didn't. Okay. Now, the main thing I want to start off with, I want to explain what this is. You've probably seen it crop up every now and again when you're typing up something. For instance, if you type SYSO, sometimes synchronize can appear. Okay. Now, this is to do with threads, which you haven't covered yet. There is a whole chapter on threads here. Right now, threads Java 6 and Java 7 was were a pain in the arse to use. All right, a complete pain in the arse to use. All right. Now, what are threads? Threads are so we are used to just one flow of control going through our program. All right. Imagine there's just one story going through our program. Do this, this happens. So it's A follows B, follows C, so on and so forth. Okay? So it's a story that goes in a linear fashion. Goes one way. Yeah? And there's only one line of control going through the program. Do you understand what a thread, what I mean by a thread is? Right. Snow White and Seven Dwarfs. Huh? But in the original book, I believe, there was. Yeah. Only one story going through it. Right. Now, Snow White and Seven Dwarfs, there could be said to be the Snow White story. Is each of the seven dwarf stories. So 1, 2, 3, 4, 5, 6, 7. That's 8. There's the what you call the owl lady who poisons her? The evil witch. There's the witch's story. Then there's the two fairy godmothers, or she 3 of them. So there's 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12. There's 12 storylines going through that one story. Okay? So you could follow the story of one of the fairy godmothers, or of Snow White, or of Josie, and who else is there? I can't think of their names. Or you could follow the story of the evil woman who poisoned her, which I'm thinking of Sleeping Beauty actually. Okay, Snow White and Seven Dwarfs doesn't matter. There's 12 threads going through that story. Okay, and they're running concurrently at the same time. Okay, as Snow White is cleaning her the seven dwarfs. The seven dwarfs are out working the mines, and the queen is plotting to kill her. And the three fairy godmothers are doing whatever it is fairy godmothers do. They're all happening at the same time. A thread is the exact same thing. All right. There's more than one flow of control going through your program. All right. So this is for now. The thing about threads is, all right. So let's say we have 3 lines of control going through your program. Okay. Does that mean your program can run 3 times faster? Not necessarily. Okay. All right. That depends on the way Windows is set up or Unix is set up or whatever. All right. It just allows you to do more things at the one time. Is the best way to describe it. That's what threads allow you to do. Okay. You can do more than one thing at the one time. All right. Now, problem with threads is that you can have 2 threads accessing the same method at the same time. Understand what I'm saying? So let's say we have a thread that's taking care of connecting to the internet. Let's say we have another thread that's taking care of security. Okay, this is all your connections. This is all your security. And you have another thread then that is constantly monitoring the user. Okay, there are 3 different threads at the same time. Yes, one is constantly doing stuff on the internet. One is monitoring your eyes, whatever. For instance, camera tracker, or there's an eye tracker on this, right? So it is constantly tracking my eyes, which is a bit freaky when you think of it. Security, every laptop, every computer you're going to be using is going to have some sort of thread running on it that is going to be constantly monitoring your machine. All right. So you can imagine we have a program that's got 3 threads of control. All right. Now, 2 threads can access the same method at the same time. So you could have the internet thread accessing this method. You could have the monitor user accessing this method. All right. Now, if you have 2 threads accessing at the one time, it's not really a singleton anymore. All right. Now, with the older threads, what could end up happening is that you could have 2 hay storage objects being created. How it would manage it, one of the ways it would manage it is it would create 2 hay storage objects. Now, there'd be copies of each other, but there wouldn't be singletons anymore. All right. So this guy here prevents, when you say something is synchronized, that means only one thread can access it at a time. It prevents another hay storage object being created by the threads. All right. So synchronized, primarily what it's for, it means one thread can only access at a time. 2 threads can't access at the same time. Okay. If 2 threads could access at the same time, there is a possibility that a second hay storage object would be created so the other thread could use it, because that's one of the ways of managing threads, was to create a second hay storage object. Okay, synchronized means threads can only access one at a time. So only one thread can access this method. Okay, so internet access it first, then security, then monitor user. Okay, they access one after another. Now it takes nanoseconds to do, so you don't notice it. All right, so that's what synchronized does. Synchronized prevents multiple threads accessing the one method. All right, which can lead to the creation of another hay storage object. That's what synchronized is. Any questions on that? Now, we do an awful lot more on that when we come to threads. Now, threads is not until chapter 7, so that'll be well after Christmas before I come to them. As I said, Java 7, pain in the arse to use threads. Java 8 is much improved. All right, you could get conflicts happening all over the place with threads, and they were head wrecking. But with Java 8, much simpler. Okay. Now, so if you're adding, or if you're changing the hay storage object in some way. Now you can't change the shed, right? That's always going to be the shed, but you can change the quantity. Okay? But if you are changing the quantity, by either adding hay or removing hay, make sure it's synchronized. Okay, because you are going to be using threads. All right, you want to make sure that a hay storage object, a second hay storage object, because one of the way of managing threads is to create a second hay storage object. Any questions on that? So if we're going to be adding hay or removing hay with a method, we need to make sure that the method is synchronized. Any questions on that? Right, I'm going to put the comment in. This is the comment. So this method adds more hay to the quantity of hay already in the hay storage object. Now, synchronized is for use in threads and ensures that no two threads can access the same method at the same time. Yeah. It'll choose once you. That's another thing synchronized to do. Okay, if it's at the same time, it'll do one or the other. Yeah, exactly. But once you synchronize them, now for a start, anyway, the odds of someone doing the same time, but it will happen, right? Once they're synchronized, it means that, as Jason said, the way it happens is, so you have two users. One is trying to add and one is trying to remove. Okay. The computer operates something called a token. All right. And it has, so whoever has the token is the method it's called. So let's say Tom is trying to add hay. Pat is trying to remove hay. Once you synchronize it, and this is your token. So it chooses them arbitrarily. Right? Unless you have said, if you could do it in such a way that if someone is trying to remove hay, it'll remove the hay first and then it'll add hay if you want. Okay? So it'll assign the token to one of them. Now it's usually arbitrary. So I'll give it to Tom. So the add hay is going to be done first. And as soon as the hay is added, then that token is passed to Pat, and Pat removes hay. You can you can synchronize a block of code, which we will be doing. So the next method is going to be using a static initializer to create a singleton. The third way is going to be using a lazy instantiation, and there's something called double checking, which synchronize a block. Because if you synchronize a whole method, and if this method is going to be called a lot, now we're talking here thousands of times. When your program is running it, it's not that unusual to have a method being called millions of times, by the way. All right. If the method you're calling, if you're calling it millions of times and it's synchronized, the whole method, it will slow down your system. So a way around that is, rather than making the whole method synchronized, you can synchronize a block of code. So yes, you can synchronize the object here, but you synchronize it by putting a curly bracket around it and putting the word synchronized in front of it. Now, but there's a couple other steps I have to do before we come to that. Okay, so I'm I'm actually going to copy and paste this and you can download it. Because there's a lot in it. Second. Oh, fuck, I forgot that. Hold on. So, synchronized recent threads ensures that no two threads can access the same thread at the same time. Threads of line of control that run through your program. Up to this, we've used single threads, but you can have multiple lines of control going through your program at one time. This also means that the object call in this method is locked and can't be accessed by other methods when this method is in progress, meaning the amount can be modified while this method is using this object. So synchronizing gets rid of that issue here, right? So it will pick one of them. So it'll arbitrarily pick one of them. So that means while hay is being added, remove hay won't work. Okay? If a static method is synchronized, it means that the static variables and static methods used in it are locked. Static variables used in it are locked. So anything that's non-static isn't locked. All right? Now I'm going to do the remove hay one. All right? So now we'll be going through all of this again tomorrow. I might even do another one. I'm thinking I'll do another one and I'll call this shop. Is that okay? I'll do a kind of a stock taking software for a shop. All right. So I'm going to do a zoo and I'm going to do a shop. So I'm going to spend probably the rest of the week at these guys. All right. So if you don't get them now, don't worry. We're going to do an awful lot more of them. We're going to be fed up with the fuckers. All right. Right. Now, adding here. Right. Now, so here's the rules. Here's our shed again. And we've been taking away hay all day. All right. And we now only have 10 bales of hay left. But we're about to go to the elephants, and the elephants want 15 bales of hay. Now, so what we want to do is, if the amount we're taking out is greater than the amount that's left, we don't want them to do that, obviously. Yes? So, if the amount is greater than the amount is there, we don't want any hay removed at all. Okay? If the amount, so taking out 15 bales, there's only 10 bales left, we don't want them to remove any bales. Okay? Now, so 10 bales left. If he's only taking out 5 bales, then he is allowed to take out 5 bales. So he's not allowed to take out any more than's already in there. Now, I'm going to do it in such a way that it's going to stop him entirely. So if he goes to take out 15 bales, he can't take out any bales. Do you understand that? Okay, because I'm going to do it in the zookeeper class. What the zookeeper class is going to do, he's going to call this method if he takes out too many. And it's going to, the zookeeper is going to take care of that. All right, I decided to keep our methods, I'm keeping the methods smaller. But when you do that, that means you're going to have more methods. Do you understand that? I could have an add, I could add the hay inside the remove hay one, but I'm not going to do that. The zookeeper is going to do that. All right, so, hello. So again, it has to be synchronized. So it's public, synchronized, void, remove, int amount. Now, so if the quantity in the shed is less than the amount the zookeeper wants to take out, okay, it's not void, by the way. It's going to return true or false. All right? It's going to return true or false. If it successfully removes hay, it's going to be true. If it doesn't remove hay, it's going to be false. Yes? So the zookeeper is going to use this. So if this returns true, he take out the hay. If this returns false, he'll add in some more hay and then he'll take out the hay. Do you understand that? So we're letting the zookeeper taking care of the adding hay and removing hay. If quantity in the shed is less than the amount the zookeeper wants to take out, I'm going to put in the print statement. So this is going to flash up on the screen to the zookeeper. I'm going to say there is not enough hay in the store for the amount requested. Okay, and we're going to return false. Okay, so if quantity in the shed is less than the amount requested by the zookeeper, return false. Okay, otherwise we go quantity minus minus equals amount, and we're going to say amount hay removed, and if the hay removed, we're going to return true. Okay, so if it returns false, the zookeeper has a method called feed. Right? He's a method called feed, and he'll either remove hay, he'll either remove meat, or he'll either remove vegetables. If he doesn't successfully remove hay, he's going to add 100 bales of hay. That's the way it works. Okay? So if he doesn't have the right amount of hay, he's going to add 100 bales and then he removes whatever amount of hay he wants. Does everyone understand that? Okay? But this method is just concerning itself with removing the hay. If he has enough hay in the shed, it'll return true. 10 bales in the shed, he's only removing 5, this will return true. 10 bales in the shed, he tries to remove 15, this is going to return false. Okay, so I'm going to put it in here. When a zookeeper gives some hay to one of the animals, this method is called. If the amount the zookeeper wants to use is greater than the quantity of hay in our shed, then this will return false, and the zookeeper will not be allowed to take out that amount of hay. Okay, so I'm going to do the second part. If the amount zookeeper wants does not exceed the amount of hay in the shed, then he takes that amount from the hay in the shed and returns true. Okay. Now, right. So that's our singleton class finished. Right? That's our singleton class finished. So the next thing we need to do, we need to go to our zookeeper class. Okay. Now, I don't have classes for each one of our animals. All right. Because it'd be overkill. Right. All I care about is that I'm either feeding elephants. Let's see what I say. All right. I just said I'm feeding elephants and nothing else. Okay. I only care about feeding elephants and nothing else. Is that okay? So this is just to simplify things. I could have done animal classes and then I could have had some classes of elephant, but it just gets more complicated then. I'm trying to keep it as simple as possible. Is that okay? Right. So I am going to go to the zookeeper class. Okay. Now, there's only going to be one method in this class. All right. So this is the method. It's going to go public Boolean feed elephant. Now, so this is the amount of elephants we want to feed. Right. So I'm just going to say return false to start off with. Right. So what is this method? So this is a method that will use a hay storage singleton to see if we have enough feed for each of our elephants. Count is the amount of elephants we have to feed. Will return true if enough hay in storage or in shed and the elephants are fed. False if not. Right. So I'm going to hard code how much bales of hay an elephant eats a day. So I so we need to go int amount needed. So I'm going to say each elephant eats 5 bales of hay a day. Okay. So put this in here. Each elephant eats 5 bales of hay a day. So amount multiplied by 5 is the amount of bales we need for the day. Okay, so we've int amount needed is equal to count. Is everyone okay with that? Yes? Right. Now, here, this may or may not create our hay storage object. Right? This next line. So hay storage is equal to hay storage.get instance. Now, if this is the first time that we've accessed the hay storage class, then this will create the hay storage instance. But in our case, if I go back here, it's not. Okay, it's already created. So here, even though we're in the zookeeper class, it's still accessing the same shed that was created here. Okay, it's the one shed. So it doesn't matter what's accessing the shed, it's still the same shed. All right, so you don't have to go redefining stuff or recreating it or copying or casting or any of that shit. All right, it's still the same shed with differing amounts of hay in it. All right, so we're here. So I'll put this in here. This may or may not create our hay storage object. Okay, if it's first time the hay storage class is being accessed, then the hay storage object called instance is created. If it was already created, then this is just accessing the same object. Okay, so this may or may not create our shed. Okay, now, so we can say that this may or may not create our shed. We can definitely say this does not create our shed, right? The reason being because we can see that line. If it hasn't already been created, that guy creates it. Okay? So it doesn't matter. When we get to this line, our shed is created. So this is just accessing our shed. Okay? Now that's a good a time as finishes anyway. Alright? So I'm going to finish off this zookeeper one tomorrow. Also, I'm going to do a shop. Alright? I'm going to do a shop with these type of singletons because these are the easiest singletons. The other two types of singletons are a bit more complicated. So I'm going to make sure we know what a singleton is. I'm going to make sure we know how they operate. And then I'm going to show you the two other ways. One is using a static initializer block to create a singleton. The other way is something called lazy instantiation, which is on the exam, and also something called double checking, which isn't on the exam, but it's useful to know. Okay, so that is us finished for today. I will upload that code. Now don't head home yet. So you can have a fag and stuff, but don't go home yet. So export that. Yes, I can. Yeah. Huh? Oh, you're still not here yet, yeah? When? When? Monday?
Yeah, on Monday I'm going to go to Joe.
I thought you said go to Dr. Joe.
Oh,
I don't think she's a doctor. Maybe she is. I don't know. She might give you a full examination. Whoa. Uh, wow. Tell us all about it. Yeah, you can. Go on. Sound. See. Go on. Yeah. Go on, Kieran. Well, well, get instance. So, what happens is, well, you can call a method as many times as you want. Okay? But the first time you run it, I go here, get instance, right? So when you call a static method for its first time, what happens is all the statics in the class run. So this static runs, and this static runs. Okay, so this static runs. That only runs once. Okay, so that's only created once. So if I call it a second time, that doesn't run. Okay, so you can call get instance as many times as you want, but get instance will only create the instance once and once only. Yeah, it's not being defined twice. It's only been defined once because it's a stat. You can redefine something. So if you go int num is equal to 4, I can't go int num is equal to 6. Can't redefine it. That's what redefinitions. Okay. So I'll export that code. Now you might think, yeah, this isn't anything new. That's not true. This is new. All right. This is, you have to know. Yeah, you have to know these things. All right. So that is 2.5a. Five A. Save. And I will save this video. Started. So we have created a hashed, right? And our hashed is called instance. Okay. Now, instance will always refer to this hashed. We can only create one hashed. That's it. Now, what we can change though, when something is final, is we can change the variables. Okay. So we can change the variables. So we have a variable. Now you make sure that the variables are private as well, by the way. We have a variable here called quantity. Okay, so that is going to be the amount of bales. So that this is the amount of bales in our shed, which is a hay storage object. Okay, so that's the amount of bales. All right. So what we're going to do is, and this is our actual singleton, private static final hay storage. That means as soon as we call a static method on this class, that's going to happen. Okay? So the first time we call a static method on this class, that's going to happen. If we call it a second time, it's not created a second time. It's static only once. Does everyone understand that? Okay? So we make it static. That means there's only one of these per file. We make it private, so we can't access it outside the file. We make it final, which means once you create it, you can't change it. Okay? All those things taken together means it will be a singleton. Means you'll only have one of them per class. Yes? Okay. Now, we can access different attributes of this class. Okay. Now, if we want to access the actual singleton itself, we're going to access it through a static method. Now, this static method, which we've called here in examples, HeyStorage.getInstance, right? Now, so the method call is HeyStorage dot get instance. Okay, now that's the very first interaction we have with the class. Okay, if you interact with the class in any way, all of the statics run first time. Okay, now HeyStorage.get instance, that will run all of the statics in the class. So if we go up file, and it runs them in the order they are in the file. So it'll create something called a counter. It'll give a value of 0. It'll go to here, static initializer called. It goes down the screen. That doesn't happen. That doesn't happen. This happens. Okay, so it creates the Hey storage object. Okay, the Hey storage object then calls the constructor Hey storage object created. Okay, that all happens the first time we go Hey storage.getInstance. Okay, now, so the second time we run it, which is here, all right, what happens in that situation is none of the statics run. Okay, that doesn't run, it's already created. That doesn't run because it's static. That doesn't run because it's a static. Okay, so first time you run this, nothing else has happened with the class. This will create our Hey storage singleton. Second time you run it, all it will do is it will return the existing Hey storage singleton. Okay, so first time creates the singleton. Every other time just accesses the singleton. Does everyone understand that? Yes? Okay. Counter is created. Counter is the static. So it first time we run Hey storage.getInstance, that's the very first thing that runs. It's the very first thing that's given a value. If I run Hey storage.getInstance again, it doesn't run again. It doesn't have to run again. Okay, so I'll run a line of code. All right. So I'm going to go to here. I'm going to comment out these guys. So Hey storage.getInstance. All right. Save this lad. Now, so run it the first time. Singleton pattern. So static initializer called. This guy here. Okay. Now it goes all the way to down here. What does it do here? It calls the constructor. Okay. It calls the constructor. Now, when you call the constructor of a class, what happens is the non-static initializers run before the constructor. So it causes that to run. Okay, then it goes to the constructor and it prints off hey storage object created. It increments the counter by 1. So the counter is now 1. So we go down here. It calls the get instance called. Then it goes ID of object is plus counter is 1. Okay. If I run it a second time, see what happens. This is all the first call. Okay. This is second call. So we can see that the first call has created our hey storage object. And we can see the second call, it's accessing the same hey storage object. Okay. So get instance, first time it creates the hey storage object. Second time, just access it. Okay. So any static, any interaction with the class will cause a hey storage object to be created. Okay. And once created, you can create another one. Okay. But you can change the quantity. You can change the amount of bales held. Does everyone understand that? Yes? You can change the shed, but you can change the amount of bales in the shed.
Why you create count? Why it's just like not assigning one?
Why did I create a count?
We will create only ones, like you said. Like
Yeah, but I'm putting a counter in to identify it. Okay, to identifiers, and I've incremented by 1 inside the constructor. So if another singleton was being created, that would have changed to 2. But you're going to see as we're going through it, I'm going to continuously check for the ID. It's always going to be 1. Okay, so I'm going to be accessing this particular hey storage object. I'm always going to be checking the ID of it. The ID is always going to be 1. So it's identifying our hey storage object. Yeah, debug. Okay, if another hey storage object was created, ID would be 2. There would have been 2 objects created. There isn't 2 objects created. There's only 1 object created. That's why I put it in there. Okay. Now, so I have this guy here creates it. This guy here only accesses it. Okay, it's the same one because I got the same ID. Okay. Now, so I'm going to get rid of all of this shit. Right. Now, I am going to go to the hey storage method, and I am missing. I need, as I'm taking out hey, okay, so this one adds hey. All right. So let's say I've only got 20 bales. I want to add 20 bales of hay to the shed. It'll say amount hay added. So let's say if there was 20 in the hay shed, if I add 20 to it, it's now going to have a quantity of 40. Yes, quantity is the amount of bales in the hay shed. Okay, so this method is you're quite simply sending it the amount of bales are going to be that's going to be added to your hay shed. Yes, yeah. Now I made it synchronized. The reason I made it synchronized, now synchronized is all about threads as I explained yesterday. Okay, so there are lines of control that's going through your program. All right, now the reason to make it synchronized is that you could have 2 threads accessing this method at the same time. Okay? So what synchronized does, synchronized means that only one can access it at a time. Okay? Only one process can access at a time. If you had two users, two zookeepers, for instance, okay, or two animals accessing this at the same time, okay, what can happen is threads can create another object, okay. So if you don't synchronize them, you could accidentally create a second hay storage object. One of the ways the threads get around that is that they create another object, okay. So by synchronizing them, it means that only one object can access this at a time. So if one zookeeper accesses add hay, the other one can't access it. Now it all happens like that. Okay, we're talking here about milliseconds, nanoseconds even. Okay, as someone is inputting it, it's not as someone is inputting it as soon as someone presses the enter button. If some two people press the enter button at the same time, it'll pick one at random. Okay. Yeah. Yeah. Well, here's the thing, right? When you synchronize them, that means the whole object is locked. Yeah. No. So the object is locked, but I mean it's only locked for a nanosecond, so you don't notice it. So if someone is adding in hay, you can't remove hay until the hay is added, or vice versa. Okay. So it happens in a nanosecond. You don't notice it. Okay. Now there is issues with synchronization, namely synchronizing methods can make your method slow. There is an alternative to synchronizing a method. You can synchronize a block, which we'll be showing you later on. Okay? And we'll be doing more about synchronize when we come to threads. Now, threads is not until chapter 7, so we won't be doing threads till after Christmas. Okay? But that's all synchronize is for. It's for threads. Okay? Now, so this is going to add the hay. So let's say if we have only 20 bales in the shed.
Assistant contact extension 238. General Assistant contact extension 238. Thank you.
So we add 40 to it. It's going to say 40 hay added. So it's going to be quantity is equal to 20 is equal to 20 plus 40. So then we're going to have a quantity of 60 inside it. Yes? Okay, 20 bales of hay. Now,
So it's like calculator, yes? Just actually everybody in our class have own number, and actually we can put it like separate, and it's returned back to like.
no, it's like there's a box there. The box has got 1,000 sweets in it. Each one of you can take sweets out of the box. Each one of you can also add sweets to the box.
But why we can't take all together like let's say we six, and we will put all together like a pen, and we'll take in 1 second. So what point like
What you
make
mean?
it synchronized? Like only one per.
No. The whole idea of synchronization is to stop threads accessing the one object at the same time. It's not about accessing. It's not about accessing this method. Okay. Right. For instance, if you don't synchronize these, you can have a situation where one thread is trying to add something, another thread is trying to take away something. If you're trying to do the two of them at the same time, it's going to lock it. Okay? So you can't add and take away at the same time. You can add at the same time, but that's not the way it works. All synchronizing does, it locks. So when I'm adding hay, the shed is locked only to me.
So I can send this just purpose.
Yeah. Okay. When I'm taking away hay, it's locked only to me. So as I'm taking away hay, no one else can add hay. Similarly, when I'm adding hay, no one else can take away hay. Yeah. Mm-hmm. Yeah. Well, it's nanoseconds we're talking about. Billions of a second, so you don't notice it. Okay. Now, there is techniques with synchronization. This is probably not the recommended way to do it. Now, this is the one that's examinable. The thing is, if you're doing this a lot, you're locking your objects. And it can be working on, in a second, it can be doing it thousands of times. If it's doing it tens of thousands of times in a second, you are going to notice it, right? So there is another way besides this. But what synchronize does, when a thread accesses it, it has exclusive access to it. Okay, so let's say our first zookeeper, Ned. Okay, he wants to take out 20 bales. Okay, at the same time, Nelly, our zookeeper, wants to add 40 bales. Okay, now what synchronization does is it'll pick one of those processes. Okay, it'll pick one of them. So let's say Ned takes out 20 bales first. Okay, that means we've got 0 bales in it. And then Nelly adds 40 bales. So now the shed has got 40 bales in it. Yeah? Okay. Or Nelly adds 40 bales. Nelly adds 40 bales. And then Ned takes out 20 bales. Okay? So it just ensures an order. That's what synchronization is all about. Okay? It makes sure that that a second single isn't created, and B, it doesn't lock up your program, because your program can get locked up as well. All right? So that's what synchronization does. All right?
So very narrow like right now, because actually, why not take 20 and put 40 in the same time?
Because then I wouldn't be able to show you how it works. I'm just showing you how it works. You could, of course, if you want to do that. But I'm showing you how it works. That's it. Okay? All right. Public synchronized void add hay, system amount add hay. And also, you're not going to be wanting to add hay every time you take out hay. And also, you're not going to be wanting to take out hay every time you add hay. So it's just a lot simpler just to go add hay to remove hay. Public synchronized void add hay, amount hay added quantity is equal to amount. This one here. Now, if the quantity you're trying to take out is more than the quantity that's in the shed, we're not going to allow you to take it out. So public synchronized boolean remove hay, it returns false if you can't remove the hay. So if the quantity you're in your hay shed is less than the amount you want to take out, it won't allow you to take it out. Okay. Otherwise, you can take the amount out of the quantity. It's going to say the amount removed, and it's going to say return true. Is everyone okay with that? Yeah? Right. Now, I'm going to go to the zookeeper class. So, now we're only going to have the zookeeper feeding elephants for now. Okay? So, the count is the amount of elephants he wants to feed. Now, we're going to say each elephant eats 5 bales of hay. Okay? So if I pass in 5 elephants, that means you have 25 bales of hay gone. Yes? Simple enough. So, now, if we have already created the hay storage object, this is just going to access it. If we have not already created a hay storage object, this is going to create it. Okay? So, it'll either access an existing one, or if one is not created at this stage, it'll create it. Yeah? Is everyone okay with that? Okay. Now, I even did it twice here to show you that it's so this one here, if it has not been created, this will create the hay storage object for you. This here is always accessing a hay storage object. That's never creating a hay storage object. The reason I put that in there because that's liable to be an exam question. Okay? So, now, I haven't finished this. There's one other method I need to put in the hay storage class. Now, we need to know how many bales of hay are in. So as we're taking out bales of hay, okay, the quantity is going to be changing, yes? Okay, so we want to know the quantity. Now, any method of the hay storage class should be synchronized. All right, any method of the hay storage class should be synchronized. That prevents multiple threads entering it. Now, I'm going to leave that one in there. It's not a true singleton. I'm just leaving that in there just to show you static methods are called. Okay. Now, so yeah. So I rephrase that. Any instance method of the hay storage class has to be synchronized. Is that okay? Any instance method. You can't, not the static ones. You can't synchronize statics as far as I know. You can. Yeah, but I don't know how synchronization works with statics, to be perfectly honest. Okay, so you don't synchronize the statics. I'm not too sure how they work with statics, to be perfectly honest. Now, but any instance methods, if you want to make sure that they're singletons, they have to be synchronized. So we create another method, public synchronized int get hay quantity. Okay, return quantity. Okay, so what is it? So this is going to return quantity of hay in the store. In the hay storage object or our shed in our hay shed and zoo. Okay, that's our hay shed. Now, because quantity is a private variable, if we want to access it outside of the class, we have to do it through a public method. Yeah? Quantity is a private method. Quantity is a private variable. So we access it via a public method. Now I'm going to go to the zookeeper class. Now, so hay storage.get hay storage instance. So what we're doing here, we feed elephant. Now, so we have a variable up here called amount needed. So that's the amount of hay bales we need. Okay, so we're going to do a little calculation here. So if I'm going to say hay storage dot get hay quantity is less than amount needed. Okay, we're going to say hay storage dot add hay amount needed by 2. Now, what I'm doing here is, if they have, so what I've done here, so if the amount of hay that is needed is less than the amount the zookeeper wishes to take out, add twice the amount the zookeeper needs, i.e., if we only have 10 bales of hay left and the zookeeper wants 40 bales, we will add 80 bales of hay. Okay, just to make sure. Okay, so if we've only 10 bales of hay left and the zookeeper wants 40 bales, we will add 80 bales of hay. That's what we're doing there, which will give us a grand total of 90. And then we take 40 away from that and we have 50 left. Yeah? Okay, so now the benefit of doing it this way is that he's always going to be able to take out some hay. If there isn't enough hay in it, he just adds hay to the hay shed. Yeah? So this only runs here if he doesn't have enough hay. Simple as that. Is that okay? Right. Now, so we know we have enough hay at this moment in time. Okay, so I am going to go Boolean fed is equal to hay storage dot remove hay. I know at this moment in time that I do have enough hay in the hay shed. Okay, so amount need. Okay, now this returns a Boolean. It just returns a Boolean to say whether they're fed or not. Now the way this is set up, they're always going to be fed. Yeah? Okay. So we're just going to have a print statement to the screen. If fed, I'm going to say elephants have been fed, and we return the fed. Okay, so this here ensures that if we don't have enough hay, it's going to add double the amount the zookeeper needs. Okay, so we start off with 10 bales of hay. The zookeeper wants 40. We'll add 80 bales of hay, so then we have 90 bales of hay. Okay, we will add 90 bales of hay with 80 bales of hay, so the shed now contains 90 bales. This one here. This takes hay from the store. This returns true if the hay is taken from the store and fed to the animals. This returns false if the amount of hay requested is greater than the amount in the store, and the hay is not moved, or typed up first, from the store. Now, the way I have it done here, there is no way I could have it. Yeah, but I'm just doing it this way, okay? It's I just want to return true or false that says that the elephants have been fed. That's it. Okay. Now the way I have it done, it's actually is a way to do it, but I won't say that for now. Okay. Very complicated, but it's possible. Okay. So This takes hay from the store. This returns true if the hay is taken from the store and fed to the animals. This returns false if the amount of hay requested is greater than the amount in the store and the hay is not removed from the store. Now it's very difficult for hay not to be removed from the store. Okay, so if fed is true, means elephants have been fed and the hay was successfully removed from the store. Now, okay, now I'm going to get this in operation. Okay, so I'm going to get this in operation. I am going to go back to examples. Now I'm not going to even bother creating an instance. Okay, haven't even created an instance here. So I am going to create a zookeeper. Okay, and I need to see what variables I need to pass to my zookeeper. Oh, it's capital Z-O-O. It's capital K. Okay, now zookeeper Z is equal to new zookeeper. Now I am going to go, I want to take out, I go Z dot feed elephant 10. So we start off with 100. So it's 5 multiplied by 10. 50 bales of hay removed. We now have got 50 left. Elephants have been fed. Yes? Okay. And you see that the hay storage object has been created. Yeah? Because where was it created? I go here to the zookeeper. I go to feed elephant. It's created there. Okay. That is just accessing a second time to show you that you can. Right? So that creates the hay storage object. All right, 50 elephants. So I'm going to, so we know now there's only 50 bales left. So we're going to feed 20 elephants next. So that's 100. All right. So we don't have enough bales of hay. So we should be adding 200 bales of hay. Yeah. So 200 hay added, 100 hay removed. Elephants have been fed. All right. That's a singleton. Now, do you want me to do a shop? Do you want me to do a shop? Stock taking for a shop. Yeah? No, we fed it 30.
Yes, but 2 times. So 30 multiplied by 10 is 300. Or another.
No, we start off with 100 bales.
No, but it's only 100 remove it.
Hold on a minute now. We start off with 100 bales. Okay? So 10 elephants. They each eat 5 bales of hay. That means 50 bales are removed. Okay? Now, next one. 20. Okay? So that means now only 50 bales of hay left in here. Okay? There's 50 bales of hay in here. Now, 20. We're trying to take out, that's 100 bales. We can't take out 100 bales. Okay? So what we do is we add 200 bales, twice the amount we want. Okay, so then only after 200 have been added can the 100 be removed.
Where if they've gone in this in console, actually only
There we are.
again.
Okay, because the get instance method, I have all this shit in it here. Okay, get instance called, get instance called. But 50 bales have been removed. Okay, right now. Now the meat storage object is going to show you a singleton by using a static initializing block. Vegetable storage is going to show you a singleton with synchronizing a block of code rather than synchronizing a method. All right. So I'll show you how a shop would use a singleton. Okay. So show you how a shop would use a singleton. So I'm going to create a object called, hold on a minute now, stock. Okay, I'm going to create called stock. Now, so we're only going to deal with 3 products in our shop. All right. So there's going to be 3 products in our shop. So we're going to go private int. We're going to say bread count, or just bread. Okay. So what is this? This is amount of bread in stock. Next one is private int milk. This is amount of milk in stock. Next one is private int butter. This is amount of butter in stock. Okay. Now, so I'm going to give them, I'm going to hard code in values here. So when we first open our shop, we're going to have 500 loaves of bread. Okay. We're going to have sold in 1 liters, 1,000 liters of milk. And we're going to have 700 packs of butter. Now I'm going to do the same thing here. I'm going to go static int counter is equal to 0. And I'm going to have also int stock ID. So I'm going to create a private constructor here, private stock. And I just want to show you that the stock object is being created. And again, just to counter plus plus, ID is equal to counter. Now, what stock ID? Sorry. Now, we're going to create our variable inside here. So it's going to be private static final stock I'll call it S instance, stock instance, is equal to new stock. Okay, so this runs only once. Now, so we need to go public static stock. I'm going to call it get stock. And we're going to say return stock instance. All right. Now, so we want to create a stock object. Very easy, create. So when we call, if this is the first thing done with the class, this will create our stock instance object. Okay. So I'm going to go to the examples. I'm going to go down here, static void ex3. Is it ex3 or x? Which one? Oh, ex2. ex2. Now, so it's going to be stock dot get stock. Oops, it's all right. Yeah. Go to my main. Stock object created. Yeah. So that's our object created. No problem there. All right. Now, so we want to be able to. Oh, the stock is going to be the amount of things we have on in the shop. Yes. So as people are checking out, what's going to be happening? As people are checking out stuff from your shop, what's going to be happening? Stock is going to be taken away. Okay. So now, if I thought of this better, and we're going to keep it simple. So I'm trying to think. Now, ideally, I should have done a class called, or an enum, actually. Easier, an enum would be, I'll change this. Okay. I'm going to go private enum products. Okay. And we have bread, milk, and butter. Hello. Yeah. Okay. Well, I'll have to ring my niece and get it off her because she's going to give it to me. So could I ring you? Could I call? I'll actually call down to you at lunchtime and give it to you. Is that okay? Okay. Good luck to you. Bye. Thank you. Okay.
Assistant contact extension 238. General Assistant contact extension 238. Thank you.
Yeah, I'm just trying to look at this now. and you probably want to make it a bit more involved. I tell you what, can I come back to this? And I'll do the other types of singleton, and then I'll come back to this. Is that okay, Derva? Okay. To them? Well, what you do is, do you remember these guys? You can have constructors inside an enum, remember? So you can have values inside of these. So we can say amount. Right? So that's what you can do. Okay? So it's a bit more involved, so I will come back to it. Okay. No. No. I'm not going to have counters to each one of the types because I'm going to have an amount in here. So I'm going to be directly assigning them. And I will have a method inside the enum that's going to be taken away and all that sort of thing. Okay. So just to make it actually easier to understand, it's kind of counterintuitive. I have to put in more complicated structures to make it easier to understand. All right. But I will come back to it. All right. Just need to think about it a bit more. Now, there is different. So we've seen a singleton. All right. So we have a singleton here, and the rules are you make the constructor private, okay? You make all of the instance variables of the class private. You have to create an instance of the class inside it, and you have to make it private, static, and final. Then you have a public static method that accesses that variable, okay? So your constructor has to be private. You need to create an instance of the class inside the class, and it has to be private, static, final. And then you have a public static method that can access it. Okay? Now, any of the instance methods needs to be synchronized as well to make it a true singleton. Right? So there's the things you need to know. Constructor needs to be private. The variables of the class need to be private. Okay? They should be private as well, actually. Okay? So the variables of the class should be private. The constructor should be private. You need to create an instance of the class inside the class. It needs to be private, static, and final. Then you have a public static method to access the instance of the class you're after creating. All of the instance methods need to be synchronized. Is that okay? Right. Now, for the second type of singleton we can use is this type. Right. So what am I doing here? I'll put in here. So creating our meat storage singleton reference and using a static initialization block to give it a value. Now, the first type, we have it all in one line. Okay? The first type, we have it all in one line. Public static final haste storage instance equal new haste storage. Right? That's the simplest way to do it. Now, you can also do it by having, first of all, we do this. It's still private. It's still static. It's still final. Okay? And I call it instance. Now, we get an error there straight away. Why are we getting an error there straight away? Why am I getting an error there? No, because it's final. No, this is meat storage. It's final. Okay? So this is final, it needs a value. Oh, no, write it down. Okay, now this is final, so it has to be given a value. Okay, now, so if you just leave it like that, it's going to give you an error. All right, now this is just another way of doing it. I don't know is there any advantage to actually using this, but it's just another way of doing it. I don't see the advantage myself. So you create a static initializer. Okay, and inside the static initializer, I'm going to go here, creating our meat storage singleton in a static initializer. Okay, so I go, now I have, before I do that, I have my constructor which is going to be private meat storage, and I just to make sure it's being created, meat storage object created. Now, so inside the static initializer, we can access only statics directly. Instance is equal to new meat storage. Okay, so this initializes our meat, our private static final meat storage area. I don't know again. It's just not the way of doing it. Yeah, could be. Yeah. Yeah. Well, right. So you can guarantee the order is going to be. Well, you can the other way as well. All you have to do is just put it ahead of that one. Yeah. So I don't know what the advantage is, to be honest, because you could use the other way and just put the creation of the static at the very top of your file, and then it's the first thing that's to be created. Do you understand what I'm saying? No, they're all static initializers. They all just go in a row. That's it. So what's the advantage? I don't know. Okay, it's just another way of doing something. Now, maybe, right, here's what could happen, right? Whatever happens inside here will happen before this guy. So let's say there's some sort of coding you need to do before you give it a value. That's what you use it for. Okay, that's what you use it for. So if you need to do something before this is given a value, or if you're getting a value from a database, that's exactly. So if you want to do something before it, you put it in a static initializer. That's what you do it for. Okay. So if you want to do something before you give this a value, then yeah, but even with that, sure, you could just create. I don't know. Yeah, I suppose so. Yeah, to give it a value, i.e., get values from a database. You would use I get values from database, or do some calculation based on some other value. Get some, or do some calculation based on some other value. Okay, so instance is equal to new meat storage, and it operates the exact same way as the other singletons. Okay, there's no difference. All right, so you again have a method, public method, public static meet storage get instance, and this return instance. Okay, so it operates the exact same way. You need to make the method synchronized as well. Okay, so we'll just say public synchronized add meet int amount. Public synchronized void. Okay, right. Yeah, it's all right. So public synchronized void add meet. You still need to make the methods that add and take away or do anything with them. You need to make them synchronized. Yeah. So make instance methods. Now, you don't have to make those methods private. Well, actually, you shouldn't make them private because you're trying to access it outside the class. You're trying to add meat to it. You're not changing the singleton. You're not changing the freezer. You're just changing the meat that's in the freezer. That's all. Everyone okay with that? Now, the last one. Vegetable storage. Right. So I'm going to show you this way is synchronizing. Yeah. So this is called lazy instantiation of a singleton. Okay. So what is this called? This is lazy. Yeah. So you're going to be coming across this every now and again. Actually, there's a few more other things. Lazy instantiation. All right. Now, instantiation we're used of when we create objects. So if we do this, all right, the dog is created. Now, it might be at the top of your program, might be the very first line of code, but you mightn't use it until line 50,000. Yes? Yeah? That's, I suppose that's instant instantiation. Now, lazy instantiation is objects are only created as you need them. That's what lazy instantiation is. Okay? Because if you have a lot of code, you might forget you have that at all. You mightn't use it at all. So lazy instantiation, at least you see it right. I want to use an object so it's created there straight away. That's what lazy instantiation is. All right. So let me. No, it just means you create them as you use them. It could be said that you create an object in one line, you use it in the next line. That is lazy. You could say that's lazy instantiation. Okay. So, or you create an object and call a method. Yeah, it's you're using objects. You create objects and you use them straight away. Okay, so vegetable storage uses lazy instantiation of singleton, which is delaying the instantiation of singleton until the static get instance method is called. Now, so this is a cold room for your vegetables. Okay? You're not going to create the actual object until you need it. That's all you're doing. Okay? Now, but you create the reference in the usual place. All right? So, I'm not sure what I mean by that. Private, static, now, I can't make it final because with lazy instantiation, you're never sure, are you going to actually create an object? Okay? You only create an object if you need it. So you create the reference, yes. Okay? But you can't make a reference final if you're not going to use it. All right? So lazy instantiation, I don't know what's lazy instantiated. A singleton using lazy instantiation is not final. Okay? I'll say this here. A singleton using lazy instantiation cannot be final. Okay, so I'll give you more example. So can't be final as only make final if you can definitely say that this variable will be given a value. Because that's the whole idea of lazy instantiation. You may or may not use it. Okay? So we are relying on the getInstance method. To give value to this variable. If you are relying on a method call to give a value to a variable, it means that this variable might not be given a value, as the method might not be called. Okay, so to recap. Right, so lazy instantiation means we only give value to our singleton as we need it, okay? And we give value by using the getInstance method. Now, by using the getInstance method, that means that you may not give a value to this. So you can't make it final. Okay? So by using lazy instantiation, what can your singleton not be? Your singleton can't be final. Okay? So the direct instantiation of the singleton has to be final. Using a static initializer has to be final. Using lazy instantiation, it cannot be final because it may not be used at all. Okay? Now, the other rules still hold true. So you need to make your constructor private. Just have a print statement. Now, so I am going to create a new public static synchronized get instance. Now, public static vegetable storage get instance. Okay. Now, this is what creates our static method. Okay. Now, here's the thing though. In where? Yeah, yeah. Right. So now, if I leave it like that, will that work? Yeah. Right, because if I just do that, now remember that that is given a value null. A final variable isn't given a value, okay? But a private static variable is given a value of null. So if I just go return instance, it'll give null, okay? So I need to check for null. I don't have to do it with the final variable because a final variable can't be null, okay? So I need to check for null. So if it's null. Now, that means the constructor hasn't run, by the way. If const instance is null, so I'm going to say this is going to be creating it. Lazy instance vegetable storage so if it's null, it's going to go instance is equal to new. So the first time it comes into this, okay, now so all the statics run, so that's going to run and that's going to give it a value of null. Does everyone understand that? Okay, so when we run the vegetable storage, it runs this one first, then it runs this, which means that instance is going to have a value of null. So if it is null, it's going to create a brand new vegetable storage object. Okay. Now, when your value has null, a vegetable storage object doesn't have an object hasn't been created at this stage. It's only here that the object is created. It's created the first time it runs in, because the first time it runs, that will run. It'll give instance a value of null. So if instance is null, prints off that. That's going to create a new vegetable storage object.
Provide some number, I guess.
No, we don't. I didn't bother putting a counter in here. I suppose it's not hard to put in the counter.
No, but it's nothing inside. It will not be null as well.
Well, now it won't be null. Okay, because right there. So that's all that's in this class. Okay, so I'm going to be calling vegetable storage dot get instance okay, vegetable storage gets instance. Okay, so all the statics are going to run the class. That guy run. That means instance is going to have a value of null. Okay, so runs this method. If instance is null, yes it is. It's going to print off lazy instantiation of vegetable storage. It's going to get instance is equal to new vegetable storage. It's going to return that. If I run it a second time, okay, that doesn't run. Okay, it's not null, so it just returns the instance. Is that okay? It does. Well put, Jason. Okay. Now, yes, it does. So I'll just put the comment here above it. So first time we call this method, instance will be null. So if instance is null, it will create our vegetable storage singleton. Otherwise, it's not null and will return the vegetable or singleton that is already created. Okay. Now, same thing again here. So the main reason something is synchronized, it's not necessarily because two threads are going to access at the same time, because you can actually manage that now with functional programming threads. What synchronized really is all about is, as I said to you before, I'll say it again. If your method is not synchronized, that means if you have two threads accessing the one singleton at the same time, it can't access one of them because it's locked, so it'll create a copy. So synchronizing stops you from creating copies of your singleton. Okay? That's really what it does. But it ensures that only one thread at a time can access this object. Okay? So one chef is going into the cold freezer room to get out a head of cabbage. No other chef can go in while that chef is in there. Okay? Simple as that. There. So both lazy instantiation is on the exam. The static initializer method is on the exam. The direct implementation of the the direct implementation of the singleton is also on the exam. Now, this is not on the exam. I'm going to show you here, but it's probably a better way to use the synchronization rather than this. Okay, so now it says it's not on the exam, but I'm slightly unsure of that. I'm not too sure. Right. Yeah, definitely. Yeah, definitely. Yeah. You are. Um, yeah, you probably are. Now, so this is one way of getting the instance. Okay, this is another way. All right. So we make the method public, static, the vegetable storage. I'm going to call it get instance 2. Right. So I am going to say if instance is null. So I haven't done any synchronization here. Okay. All right. So we're still inside this. So if we just want to, we can synchronize a block of code. Okay, so I'll just put in the comment here. Put in this comment. Now, so the problem with synchronizing a whole method is that it puts a block on the whole object, right? Now, we can put a block on just this part of the code, okay? So you can synchronize a block of code. So how do you synchronize a block of code? This is how you do it. So synchronized BEGETBLE dot class. Now, I'll type it out first and I'll explain it. If instance, let's say that twice. Yeah, I don't have to say it twice. Actually, I put it in just in case. Instance, null. Instance, is equal to new. Right, now, I don't really have to put in that second instance as null. Now, what I'm doing here is, so, now, if we synchronize up here, every time we use this method, and this is the only way we can access the vegetable storage. Bear in mind, we could be accessing this thousands of times, right? Every time we use this method, it puts a lock on the object. So for the length of all of this method, it puts a lock on the object. Yes? You understand that? Right. Now, here, what we do is, it's not the whole method that puts a lock on the object. It's just this block of code that puts a lock on the object. Okay? So only while the object is being created is the object locked. Okay? As you're creating the fridge is locked. That's the only time. Okay? Or the specific piece of code that's adding something to your fridge. Or the specific piece of code that's taking something away from your fridge. Okay? Now, how do you synchronize, or how do you lock it? You just go synchronized. What are you locking? You're locking that object. Okay? There's only one of them created. So you're locking that object just from there to there. Lock-ins. Now you don't have to put instance is equal to null there. That's just that's something called double checking. It's double checked locking. That's what it's called. Okay, that's just a double check. No harm to put it in. You don't absolutely positively have to put it in. All right. Now this is more efficient than synchronizing the whole method, because your method could be calling other methods and doing all sorts of things. Right. One method very, very rarely works in isolation. Okay. You nearly always have a case if a method is calling a method, which is calling another method, which is calling another method. While all that's happening, your object is locked. Do you understand that? All right. With this way, the freezer is only locked as it's been created. Similarly, let's say if we're going to add, hold on a minute now. So after all that, go down here, there's the lock ins. So this is the end of the if statement. So this is the end of the method. So we return an instance. So with this, now, if we didn't have this, okay, if we use this guy up here, every time we want to access our vegetables, it's going to put a lock on the fridge that holds our vegetables. Okay, whereas here, the lock is only put on the fridge when we're creating the fridge. Okay, similarly, let's say we have a add method. So it would be public. Let's just have a look at a minute here now. That's just telling us what are we synchronizing. We just say what we're synchronizing. It's the vegetable storage class. It's locking the object, and there's only one of them created. So that's the same as saying lock this class. Okay, that's basically what it's doing there. So whatever is calling this, it's only for these 2 lines of code is the vegetable storage object locked. That's it. Just give me a minute. So if we have public synchronized, public void add hay or add meat, add vegetables even. And I'm going to say int amount. Now, that's when you want to lock a static object, you say vegetable storage.class. Yes? Okay, so this is what? This is synchronizing, which is in effect the vegetable storage static class, vegetable storage class, which is in effect locking the vegetable storage static singleton called instance. So it's only locked for 2 lines of code. All right. Now, if you want to lock while you're inside, so we've seen with you can synchronize the whole method. If you want to synchronize a instance, so if you want to synchronize a block inside an instance method, what you have to go is like this. You have to go synchronized this. Okay. And I'm going to say, what did I say up here? What did I call it? I should say int amount, private int amount, or quantity, is that right? So private int quantity. So synchronize this. So we're going to say quantity plus equals amount. Now, so if you want to synchronize a block of code inside a static method, okay, you have to go the name of the class, the stat, and class. So if you want to synchronize a block of code inside a static method, you have to go the name of the class you're currently in, followed by the word class. So if you want to synchronize just a small block of code inside the static method, you have to go the name of the class you're currently inside, followed by class. So I'll type that in there. If you want to synchronize. block of code inside a static method. You go synchronized, name of class curtain clay in dot class followed by curly brackets. Okay, and anything inside the curly brackets will be synchronized rather than, so anything inside curly brackets. So change that. The singleton is locked only while the object is locked. Yeah, the singleton is locked only while inside these curly brackets. That way. Now here you have to use, so this is with a static variable. Okay, you can't use this with a static variable because static variable applies to all of the class. All right, so if you have an instance method inside the static and you want to synchronize it, you go synchronized this. We use this, the syntax we use for instance methods that we want to synchronize. We use for instance methods when we want to synchronize a block of code inside the method. Now, these synchronizing blocks of code is not on the exam. All right, but just to let you know, they're far more efficient, they're far quicker. You will actually notice a bit of a lag if you make all your methods synchronized. All right, you will notice the lag, whereas you won't notice the lag if you make your blocks of code synchronized. Now we do more on this when we go to threads, but I seem to remember it still doesn't do synchronizing blocks of code. Any questions on that? So what you need to know for the exam is creating a singleton using direct instantiation. So what's direct instantiation? Well, rules that apply to all singletons. You make your constructors private. You make your variables of the class private. Now, for the direct instantiation of the singleton, you create an object of the singleton inside its class. You make it private, static, and final, and you access it through a public method, a public static method. The other way is instantiating it. So you create the reference first, then you instantiate it inside a static initializer. Everything else is the same. We have a private we have a private constructor. We have a public static method to gain access to it. Vegetable storage using lazy instantiation. Okay, lazy instantiation is not making the singleton final. Okay, it's when you still make the constructor private, you still have a public static synchronized vegetable storage get instance method. Okay, but what we do inside the get instance method is, it's inside the get instance method we give it a value. Okay, they are the three methods of singletons you need to know. Okay, now I'm not going to do the shop until Friday because I realize there's a couple of things I have to figure out myself before I do it. Is that okay? That's what you need to know about singletons. You need to know direct, you need to know using a static initializer, you need to know lazy instantiation. So it's only down as far as here you need to know for the exam. All of this stuff, it's a big comment, I'll Write it down and I'll read it out to you. In practice, both method can be labor memory intensive, as you only really have to call in synchronization with the first creating the singleton. We do this following we get instance method a few thousand times. It means synchronize. So I have a link here as well that will show you best practices for creating singletons. So all of this stuff down here, it's not on the exam. So synchronizing blocks of code is not on the exam. Okay? But it's no harm to note because that is quicker than the other way. Okay? Now, so we've singletons done. Woohoo. I thought it was going to take the rest of the week to do it. Any questions on that?
About exam, vegetable, no, zookeeper. You said about exam,
Yeah.
zookeeper.
Zookeeper.
Yeah, zookeeper.
Yeah.
Line 23, 24.
Yeah.
So, if before equal high storage, it's actually 2 words, so it's not created.
This here? Right, so
yes.
if we haven't used it before that word, that sentence, then it's created there. If we have created before that guy, then so if we haven't done anything with the file before this line of code is run, the hey storage object is created that line there.
Yes, I understand, but I mean how to recognize. You said it will be question in exam, so like how.
Well, I mean, you're going to have code, and in the constructor, you're going to have code that creates a singleton. And maybe before that, you might have code that creates a singleton. Okay? So,
Recognize if before equal only 1 word, so it's probably already created and we just like.
you're just going to you're going to have to go through the code line by line, see where it was created. And the first place where it's called will be where it's created. Now, it might be line by line, right? So you might have something like your constructor at the very top, then an initializer, then your statics. You have to remember that the statics run first. Okay, it's going to be something like that, right? But you'll probably get a question something like that. Might ask, on what line is the singleton created? Okay, it might give you just those 2 lines of code. So one of the answers, it is created in line 23. It is created in line 24. It can never be created in line 24. It can never be created on line 23. So it can never be created in line 24, but it can be created in line 23. Maybe, okay? If something wasn't called before that, then it won't be created. If nothing was called before that, then it will be created in line 23. It can never be created in line 24. Okay? Yeah. Okay? Now, so we might as well get ready for the next section. So this is 2, so I will stop that video.